Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hi guys, welcome to yet another episode of the web live webinar mock interview session. I hope you guys are doing great. Let me know in the comments if I am audible to you and if everything is perfectly fine. Great. Hi Harsh. Hi Omkar. Hi Saira Kumar. I'm just waiting for some more people to join in and then we can quickly start the session. Hi Navneet. Hi Soham. Okay, I think we have enough people here. Okay, so I'll quickly introduce the student and the mentor who would be taking her interview. The student is Aanchal Singh. She is currently studying in MNNIT Allahabad. She is a fourth year mechanical engineering student. And the interview would be taken by our in house mentor, which I'm sure you would all know. He's Dhananjay with the code force rank of 1870. Apart from being a mentor, he's also working as a software engineer at Geeks only. Also, he has 4+ years of experience with competitive programming. And yep, that's about it. Okay, so Harsh says, can you provide some special tips for placement? Okay, I don't think I'm the right person to provide tips for this, but I'll surely connect you with someone who is. Great. Hi, Achal. Hello,
Hello,
Dhananjay. How are
ma'am.
you?
Hi, Sita. Hi, Aanchal.
Hello, sir.
Hello.
Great. So I have introduced you two to the audience, and now over to you, Dhananjay. You can go ahead and ask your session.
Yeah, okay, sure. Thank you. Thank you, Sita. Hi, Aanchal. How are you doing?
Hello,
How's
sir.
everything
I'm
going on?
doing good. Oh, well, great till now. It's great. Let's see what happens next.
Okay, sure. That's great. So, okay, so as you know that this is about a mock kind of interview that you just normally face in all the all the placement interviews and all. So before moving further, can you just brief me about yourself a bit, like about your college journey, in which year you are, like in case if you've done any internships or projects, we can discuss that for a minute, and then we can just move
Uh,
on to that.
yeah, sure, sir. So, a very good evening, sir. Sorry, afternoon. And my name is Aanchal Singh, and I'm currently pursuing my B.tech from MNNIT Allahabad in Mechanical Engineering Department. Though I'm graduating from the Mechanical Engineering, but I'm pretty much interested into the field of software. So, in this particular field, I am like familiar with the like languages C and C++ and the basic syntax of Java. Well, I know Java because I have done Android development. So I'll just like jump to my project. So I'll tell you about one of my projects, which is basically using which I won a hackathon. Like we were there in top 3 teams out of total 75 teams. So I like to give a description about that. It's named as Learning Easel, and it's basically an article sharing like article sharing app, like we share on an Instagram, right? But what is different, like what's differentiate us from that is basically on Instagram, users share their personal life, like what we are doing right now in our life. But we thought of building something to like a build a skills. So for that, we created a communities like if I tell you the example of communities, you can say like sports department series community or something like computer community itself. So according to your area of interest, you could join a community to get the post of a community, like a user from all over the world. Even if someone will post into the community you're a part of, so you will get the post of that particular community, and you can only post into those communities you're a part of. And a post could be upvoted and comments could also be added. and post itself could be sorted, like by default is sorted according to the time. Like initially you will get the latest post at the top, but because of the time constraint, we know everybody is busy in their life, so we added some other feature, like you could sort them according to the trends, which means basically the number of likes a particular post could get. For example, you just wanted to know, okay, what are the top trends of today, so you could go and filter the post according to the popularity, so you will get the one with the most number of likes at the top, etc. And also later on we added one more feature, which is basically, because we know that how many contradiction in today's world is going on, everybody likes discussion and all. So when a post will be posted, so we don't want any, you can say, like you can say, miscommunication happening into the group. We don't want to hurt any particular community, so for that we created admins, right? So what admins will do when a post will be posted, so first admin, like the post will go to the admins, and admins will approve or disapprove that particular post. So if a post is approved, then only it will be posted in the respective community. And also just one last feature I like to add, in which, for example, if I like some person, their post, and I want to see all of their posts, so what I can do is I can follow that person, like we follow on an Instagram, to get all of their posts irrespective of the community. And you can also bookmark a post, like to separate them into some other column and view them later on. So that pretty much was about the project, and yeah, that's it.
Okay, so like it was a pretty good project considering that, and the fact that you said that you are from a mechanical department. So just it just amazes me up literally, like as I've seen in my from a past experience, that people in the mechanical department, they have some excuses, like we are from mechanical department, we have our own jobs to do, we have we have own projects to do. But apart from that, you are still carrying out some time out for this DSA and all this part. So that's very good. That's a good job. And apart from that, your project. So basically, if I summarize that, so it is basically a clone of Instagram with some added features on that.
Yes, sir.
Okay, so that's great. Yeah. So now, so that's pretty good, and that's good to know about you, about all these stuffs. So I guess we are good to go. Like, and one more thing, like, in which language are you proficient with to code?
C++.
C++. Okay. Okay. Sure. So let's now move to the questions, right? So, have you ever heard of stacks?
Yeah.
So stacks are basically data structure. Now,
Yeah.
my question to you is that like in stack, we have mainly two operations, that is to push and pop,
Yeah.
right? And there are various ways to implement that stack data structure, right? Now, I want out of you to just implement that stack data structure for me. That is the basically mainly the two operations, that is push and pop, with the help of linked lists.
Oh yeah, sure, sir. So basically, if I'll, yeah.
So okay,
like,
wait a second, right?
No,
So what I want is to out of you is that I'll be giving you a structure of that is linked list, right? Basically, we have a structure node and all these properties are right there, right? But what I'll be so that will be provided to you. But all I want out of you is that I will give you two functions, push and pop. I will provide the I'll provide the stack, that structure for you, and you have to implement that. You have to basically implement that push and pop operations. That's it.
okay, so that's it. So basically, in push, you will be passing me, I can say, the head of the linked list, and along with that, the value which I need to push. And in the pop, you will be just still like the pop with no parameters, right? That's it. That's what it is, right?
No, but as you said that I'll be passing the head, but that might be a case that initially your linked list is empty. Then in that case, there would be no head, right?
So basically, I'll have to create the head also, like.
Yeah, like so. Okay, so basically, if I tell you that you have to implement the push function, right? So what are the parameters that you will pass in the push function?
Because like you said, you'll provide me the structure of the linked list itself, right? So that's why I thought I'll be giving the head itself. So what I was just thoughting of is head is fine, but if it's an empty, then head will be null pointer. So what I'll be doing is I'll be just checking if it's a null pointer, then I will just assign the head itself. So
okay. So do one thing, just like basically what I want to say that suppose if you want to implement a push and pop function, right? So what are all the parameters? Like basically if you want to implement something or design something, then you have to just have the basic idea about like what the structure will look like, right? So basically, if you are implementing a function, you should know what all the parameters that you have to pass in that function, right? So that's what I'm asking. Like suppose if you want to implement the push function for the stack, so what is the parameter that you will pass in that push function?
Just a value itself. We needed, okay, just push this value into the stack.
That's right. So only that value will be passed out to that, and you will I guess I provided you a hint. So
Yeah,
maybe
so I'll create a constructor for that, you can say, and then inside the constructor, I'll do the initialization part of a head.
like do our in whichever way you want. I just want it to be an optimal and efficient one, right?
Okay, okay.
I'm not bothered about the constructors and all. I'm just bothered about the two functions that you want to create for me, push and pop.
Okay, okay. So should I like go ahead with the logic?
Yeah, sure.
Oh yeah, so basically what is the push operation is, well, if you give me the linked list, then I can do two things. Like I can do the push and pop operation at the end or at the beginning. But I think if I'll do that at the end, so what I will have done, because in the linked list, we don't have the random access like an array. So starting from the end, I will have to traverse till the end and then push an element to the next of it. And then when it comes to the pop, I'll have to, erase that from the linked list itself. So that will like lead me to the big O of an operation. But to avoid that, what I can
Okay,
do is I can do.
wait a second. Can you share your screen with me and just show me
Yeah,
a
sure,
diagrammatic
sir.
depiction for that?
Yeah, sure, sir.
Like, because as you said the explanation, I just got a point in my head that and I just want to ask you out of curiosity, right?
Wait a minute, sir.
Below you have a share tree option, right?
Yeah, I got it. So now is my screen visible?
Yeah, you can open up your editor and just show me that depiction for that.
Yeah, so sir, I'm just using the online editor for that. Let me just
No issue.
erase this. What I'm trying to say is, for example, I'm creating a linked list, right? Something like this, 2 and 3 and yeah. So what I'll be having is, I'll be having like 4. I mean, I'll be having a head pointer to this one. I'm just, head pointer will point to the one itself. So if I will do all these operations at the end, for example, you want me to push, you can say, let's say just 5, right? So if I'll do all these operations at the end, so first of all, I'll check whether my head is null or not. If head is null, which means that, okay, this is the first thing I'm going to push. So I will just create a new node out of that, and then I'll just point my head to the 5 itself, right? But if, let's just assume that my linked list has all these nodes, so what I'll have to do is I will have to start traversing from the head, then from 1 I'll go to 2, then 3, then 4. As soon as I go to 4, that's the last node, so I'll make this to point to the 5 by creating a new node with the value like as a 5, right? So inside a constructor,
this is about the pushing operation.
Yeah, this is about the pushing operation. But when I'll pop, let's just say that I called a pop. For pop, I won't need anything. So initially itself, I will start traversing from the head itself. But what I'll have to do is I will have to make a previous pointer as well, because when we remove a node from the linked list, it's just that we go to the next node using the next pointer of the current node, right? So if I'll have to remove 5, so actually I'll have to make the 4 next, instead of pointing to the pop 5, now this will 4 next will point to, you can say, the null pointer, right? So in this way, I'll be able to pop the 5. But if I talk about the time complexity of this, as you can say, I'll have to traverse the entire linked list of mine, right? Starting from 1 itself. So it will be actually take big O of n. Both for the push and pop operation itself, because I'll have to go till the end. But if I want this to reduce it, then what I can do is I can like perform all these operations at the beginning itself. At the head. So let's just assume that my head is pointing to the 1. Now I want to insert the 5. So what I'll do, I'll create a new node with the named as 5, and then I will make new node next point to the 1 itself, like something like this. It will point to the 1, and then I'll make my head to itself to the 5, right? So in this way, 5 is added to the, you can say, beginning of the list. And when I want to do the pop operation, all I have to do is make head is equal to head next, and that is basically 5 will now head will become 1, and in this way 5 will be erased out of the stack, and both of these operations will just take big O of 1.
Okay, so basically you're saying that like unlike the usual cases in which when we insert we move from left to right, right?
Yeah.
If I talk about this case, 1 will be our head and 4, right? But if you're just doing the modification with the head or playing with the head, then what you're doing, you're just making the last element on the left hand side instead of the right hand side, right?
Yeah.
Because because you wanted to have a better complexity of O of 1.
Yes. Because in the, like we say, the stack implementation, library implementation, it itself is big of 1. So I pretty much just trying to compare with that to reach to that.
Okay, that's good. So can you implement both the functions for me?
Oh yeah. So I'm just assuming that I have a head, as in I'm like making a head, as in, so I'm not writing the constructor and you can say the class think of node. So is that okay?
So you're saying that so basically you're saying that you are having the pointer head as a global type.
Yeah, as a global type, and I'm not working onto the class itself, because in a class I'll have to make, a integer value, then listener pointer next, and then constructor for itself. So I'm just not doing that. If you want me to do that, I can also do
No,
that.
no, no. Like that's what I said in the in the beginning, that
Oh,
you don't need to
okay.
worry about all that classes and all the structures. You just need a head pointer, and the functions parameters will be all given to you, right? So can you implement
Okay.
that both the
Yeah,
functions?
sure. So let's just,
Yes.
I'm doing the push. So in the push itself, we have like a written type of, void, and I'm assuming that I'm inserting a, like you can say, the integer data type into my stack. So first of all, if my head is null pointer, I mean it's null, it's not pointing to anything. So all I'll have to create is, I can say, the list node, new node is equal to, I'm just, assuming that there is a constructor. Sorry, this will be list node, and I'll be passing that value to itself. Now the new node, well, instead of doing this right here, because I'll have to do this, so let's just do this outside. So if the head is null, so I'll make just, head pointing to the new node itself, and all I have to do is to return from here, right? And that's it. But if head is not null, so which means that I do have something pointing to the head, so I'll have to do what, new node next point to the head, and I'll have to make my head point to the new node, right? I think yeah, that's pretty much as it is. And if I'm popping, so I'm assuming that I'm just removing it, I'm not returning the value, right? So first thing which I will have to check is if my if my head is equal to null pointer, which means my linked list is empty, so I cannot pop anything out of it, so I'll simply return it. But if there is something inside the linked list, all I have to do is to make my head is equal to head next. So in this way, I'm just removing the, you can say, the head of the linked list, right? So if I will would you mind if I'll just try it on a test case?
No issues. Like I'm pretty much confirmed with the code that you are trying to implement. I'm just like, yeah. So you're saying that that's all about this pop function.
Yeah, let me just take, like, work onto the edge cases. If my linked list is empty and I'm pushing, so I'm making my head to it, and yeah, that's fine. If I'm popping from an empty, then I'm simply returning from there. Well, since I am not, pretty much is not, working onto the memory, so what I can do is, for that, you can say the list node deleted node, because it may, lead me to the, so all I have to do is to, call this delete deleted node, just to handle the memory, because I've deleted that node. So that will be a good
Yeah,
practice to do.
that was the
Apart from
error.
that, everything. Apart
Yeah,
from
because
that, I think
can
everything
you
is
just
working.
let me know what would have been the error in case if you have not taken this, this delete node and all these steps?
Yeah, I mean, yeah, this line 28 and 29.
Yeah.
So actually, because I'm dynamically allocating using this listener new node pointer. So now, since when we allocate the memory dynamically, so it's actually the responsibility of a user to delete that particular allocated space. If we won't do that, so we may encounter you can say that memory leakage. So just to, it's a good practice to do that, to avoid further headache in the future.
Okay, that's good. Since you have talked about memory leak, right? So can you explain me what is actually a memory leak and how does it work and how does it arises and so on?
Like, sorry, could you just repeat your question once again? Like, what you're trying to ask? I
Like
didn't understand it.
as we have talked about this memory leak, right? So can you
Yeah.
explain me what is memory leak and how does it arises and what are the ways to resolve that memory leak? What actually happens behind if we talk about memory leak? Like basically that's the question.
Oh yeah, actually I got it. So basically, when we do the static allocation, not using the constructor and all, so what does is actually now the compiler take care of this memory leakage and all. So I mean, yeah, compiler will, you can say, delete that allocated space when that particular variable will go out of a scope. But when you do the user allocation, I mean, when the user is allocating the memory to the space, so it's now particularly user should delete that space. I mean, you can say now it's available for further uses. I mean, you can allocate that particular space to some other, you can say, variables or something like that. But if you won't do that, if we will not delete that memory leakage, so what will happen, the compiler will think that, okay, this particular memory is still in the uses, and yeah, some variable is using it, so it will not allocate that space. So what will happen in the end, we may encounter the situation when all of my this, well, memory, the dynamic allocation is done into the heap part of the, you can say, the what we call it, heap part itself, right? So that could be the case that the entire space available in it is filled by all of our dynamic allocation or whatever it is. So maybe if we'll need it in the future, so what will happen, there is no space available to us, so the space will not be allocated. So to avoid that, what we do is we basically do this delete node. So in that particular case, the compiler will be like, okay, now this heap memory is available for further uses, and when we will need it, so it will be allocated. That's
Okay,
I
so
think that's pretty much what I know about it.
Okay, so there are two questions for you, right? First of
Yeah.
all, the first thing, can you just open up your screen again, editor?
Oh yes, sure.
Okay. So, okay, I have two questions for you, right? First of all, you said that the user will be allocating. So, what do you mean when you say that the user will be allocating? Because if you're talking about the stack allocation or the dynamic allocation, right? In
Yeah.
both the allocation or or the memory allocation, so user is attached with both the allocations in the dynamic and the static as well. So, what do you mean when you say when the user will allocate? What does it mean? Like, because
I mean,
are you getting
yeah.
my point? What I'm trying to say?
No.
Like basically, okay, suppose if we talk about static allocation, what does happen? You just write int array and the size of the array you
Yeah.
want to create, right? So the user is involved in that. Similarly, the user will be writing the code by himself, right? That means he'll be writing that any type, like suppose int asterisk the x equal to new int, right? All these, right? Dynamic. So what do you mean
Yeah.
when you say that the user will be allocating that stuff?
Oh yeah, actually I got it. So basically, when we do something like when we do, like you said, when the static allocation is there, so basically in that particular case, in both the cases, the compiler will be allocating the memory itself. But when we do the dynamic memory allocation, so in that particular case, we are not sure about that. Okay, what will be the space needed to us at the time of runtime itself, right? So what do I mean by the user will be allocating the space is basically when that particular code will be the running, so the user will decide, okay, what is going to be the size of, like, what is the space I'll be needing right there. So that's why we do the dynamic memory allocation. That's what I meant
Okay.
by it.
One more thing. One more thing. You said that the compiler will be handling all these memory space allocation and all these things. Are you sure that the compiler does all this stuff?
No. It's happened at the runtime. Actually, I'm sorry, my bad.
No,
And the
but
compiler
like,
will not be doing.
so what? Like, if you're talking about runtime, so where is this runtime going on?
I mean, when
Like all this
the
space
program is in
allocation
the
and
running state, when the program is in the running state.
so is it the responsibility of compiler to allocate the
No,
memory
no,
from heap, from
no.
stack, and all the stuff?
No,
So
it's not the responsibility
you
of
said
it.
that the
I think
compiler.
operating system does that.
You sure?
No, I'm not sure. I'm just
Okay.
guessing.
Okay, no. Like first of all, the basics of pointers and all these. If you're learning about linked lists and all, so what's the basic thing is that you should know first of all that what are the what I can say, the program memory. Basically, there is a thing called program memory, right? So every C++ program have some a particular amount of memory allocated for that, right? So first of all, you have to learn about, if you're learning about linked lists, like I'm talking about the pointers perspective. So you should learn about how does the pointer work behind the scenes as well, right?
Okay, sure.
So what has happened basically is that when you try to allocate dynamic memory, right? So what has happened, the code you're writing down, the compiler is just about compiling all these stuff. It has nothing related to allocating the memory, the resources, and all these things. If the task comes out to be managing the resources and allocation, it just all goes out to the operating system. So what has happened, the a compiler just write on the code and it indicates the operating system that yeah, someone has asked me for the memory, then I should have to give him. So that's what when when this new operator comes in, right? So
Yeah.
there is different topic. How does this new operator works in internally, right? So these are all the stuffs. Okay.
Okay.
So okay, one more thing. When you use a delete operation, the delete operator, what happens?
It's the deallocation.
Suppose
I mean, this destructor is called, I think, destructor of that particular class is called, and it just deallocate the memory for that space. I mean, yeah, for that
no,
node.
like that's what you're talking about. What happens in the coding part, right? I'm talking about
Yeah.
behind the scenes. What does happen when you call a delete? You said suppose you're creating in this line number 30, you have your written right list node as a delete node, right? That means you have a delete node or some kind of reference to that, or a pointer to that reference or memory, right? And you're trying to delete it. So does it actually means deleting in literal terms, or something else happens behind the scene? What does happen actually when you write down the delete in the memory terms?
I mean, the deallocation of that particular space out of heap data structure occur. Deallocation is basically freeing that space. I mean, it's now
Okay.
free and available for the users.
Okay, like, so it's bit of correct, but actually, the point is that when you write down the delete operation, what has happened
Yeah.
is that the compiler, the operating system takes back the memory that it has allocated. The pointer that it is pointing to has no longer the access, or the owner of that memory or space, right? It is no longer the owner of that memory or space. So that's why
Okay.
when you write down the delete operation, okay, one more question. If you write down the delete operation and now you try to, now after this delete operation or this delete node, what this delete node pointer will be called?
This, I think, you're dangling.
Yeah, that's correct. So that's why it's called dangling
Okay.
pointer, because it's not pointing it now. It is
The
not pointing to any
valid
memory error,
memories.
right?
Yeah.
Right. So that's all the concepts about, because that's very necessary, because if you're dealing with linked lists and this memory and resources, so you have to be very much clear about the concepts, how it is working, right?
Yeah.
Okay. So that's all about this question. Now moving to the next question. Okay.
Sure.
Consider.
Should I?
Okay. Now you can open the editor. No issues with that.
Okay. So I thought I have to stop sharing, and you're gonna share. That's
No
fine.
issues. No issues. No. That's fine. Okay. Oh, what the next question is that you are given a grid.
A grid.
You are given a 2D
Yeah.
grid, right?
Yeah.
And each cell in that grid has some values. And now your
Okay.
task is you want to reach from the top left to the bottom right cell.
Yeah.
And now you want to minimize the cost of that path from top left to the bottom right.
Okay, from top left, and like directions in which I'm allowed to move, like
Yeah.
all the 4 directions or just 2?
Yeah, all the
Yeah.
4 directions. You are allowed to move in all the 4 directions. Now your task is to find the minimum cost to reach from the top left to the bottom right.
Mhm. Okay, so could you just give me a test case for that? I mean, that would be better.
I'm not preparing a test case for that. Basically, I can do one thing.
Okay, so would you mind if I will create one and then we could have a discussion? And yeah, just one question I'd like to ask: could just the values present inside the matrix would be negative, or all of them would be positive?
All of them would be positive. Okay. So your task is,
Okay.
suppose if I denote, like, wait a sec, if I share my screen, right? I just don't have a test case in which I have a perfect answer for that, but I can just sort of give a brief idea like how it's working.
Yeah, that's what I want.
Now, what actually happens is that, suppose this is the given grid to you, and let's have some more values over here. Take 3, 2, 1, and 6, 4 again, right? So if this is the grid, then you have to reach out from this one to this one, right? So there might be various possible paths to reach out from this one to this one, right?
Yeah.
So you have to find out the minimum path, the minimum cost path, because these cell values denote the cost of visiting each cell, right? So, and all of these paths will be a positive one. Your task is to, and you're, suppose if you're at this 4th value, right? Then you can move out to left, right, bottom, and down in all the possible 4 directions, right? To its adjacent cells. Now, task is to reach out from this top left to the bottom right.
Okay.
The
So
minimum
yeah.
cost.
So like, should I go ahead with the logic?
Yeah, sure.
Okay, so sir, the first thing which is coming in my mind around is, so I pretty much was like this is a Ketra algorithm. So I'll start from the 0 0. What I'll do is I will go to all of the 4 directions, possible direction, and then check whether it's valid or not. Right. So the cost of 0 0 to 0 0 itself will be, you can say, consider the node value present at that. I mean that particular index 0 0. So when I'll be moving to the next index, so what I'll check is, I will initially, you can say that on a matrix, I'll create another matrix for the cost itself, that what will be the cost for all of the, you can say, to reach to all of the rows and column from the 0 0 itself. So for that I will be having just a priority queue kind of a solution. I'll push this into my PQ, and I mean starting from 00 itself, and then when I'll pop it out, I'll go to all of its four directions and whether check whether they are valid or not. I mean inside the matrix, present inside the matrix or not. So if they are present, so the cost to reach to that particular node from the 00, I mean it could be anything, but since I'm popping it out of the queue, so cost to, then I'll firstly compute that what will be the cost to reach to that particular value from the current value, right? And what was the previous initial cost? Well, I will initialize them, all of them, to the integer maximum, and if that previous initial cost is greater than what I am giving it, right, so then what I'll do, I'll update it. It's pretty much is a kind of like an information sharing. Like for example, if I am the current node, then I'll ask from the, you can say the next node, okay, what is the cost to reach to you from the 00? So then it will be told me, and it will be told to me by that matrix which I initialize for the cost. So this will be like, okay, this is the cost of me. I mean maybe I could be reaching from some other node, because there is the various paths for that, right? So now I'll tell you, like I'll tell her that, okay, now I'm giving you this much cost. So is I am minimum than what we have previously? So if it is minimum, then I'll update that. If it is already less than me, then I will like, okay, then I'm not gonna push you into the queue because you're already less than me. So in this way, in the end, what I'll having inside the matrix is, you can say the cost to reach all of the nodes from 00. The minimum, it will be the minimum cost. So initially what I'll be doing, I'll just returning the, because you want me to reach to the end, so I'll be returning just the last index itself of that distance matrix.
Okay, that's correct. I got your idea perfectly, right? So I have few questions based on the basis of your, the idea that you pitched to me.
Yeah.
First thing is that, why only you gave a registrar solution? Why not dynamic programming? First question. Secondly, what if you implement, or try to implement the registrar solution or that algorithm for the registrar? What does that registrar algorithm returns? So you can start with the second question first, or the first question, basic.
So like, I didn't understand your second question. Could you repeat it once again?
Okay, so the question was that, suppose you are implementing a registrar algorithm, a normal registrar algorithm on a particular graph given to you.
Yeah,
right?
Sure.
It is a normal undirected connected graph, right? Now, if you try to implement the registrar algorithm on that particular graph, which I have given to you, what is the outcome of that registrar? What does it returns?
It's basically return the shortest, like I have a source node, so it basically returns the shortest path to all of the every nodes present inside the graph from that particular show node. You can say the shortest weight, in which like weight assigned to every edges. So in the end, after I have traveled, done all of my Disagetra calculations, so in the end what I'll have is, you can say the shortest weight to reach to all of my nodes of a graph from the given source node. That would be the outcome.
So basically, if I try to summarize in a one-line sentence or a one-liner, it is the registrar is basically a single source shortest path algorithm, right?
Yeah. So that's what was in this question, a single source. But in this particular question, I'll have to output a single output. So I thought, okay, that's fine. Calculate for every other node, and just in the end, what is the output? Just to give it to me.
So my first question was that, why not dynamic programming? Because in dynamic programming, we also do the same thing, right? Because we want to pre-compute it for a current state we are standing at from the previous value we computed, right? So why not dynamic programming? Why only registers?
Well, I think because of that 4 direction. If it could have been asked to me that I could just go to 2 direction, that is the left or the down, then I would have preferred the dynamic programming. But I think in this 4 direction, so it's just that this will not be always be coming out of a straight path. There could be the case that may go to the down, right? So for example, if I am at this current node, so using the dynamic programming, I'll be computing like from the starting, what will be the like starting to the left.
Do one thing.
Yeah.
Take a grid on your editor. Just try to explain me what you're trying to do, right? So the current state or a still value.
Share the screen.
That would be better.
Okay, like is my screen visible? Like, so can you see my screen?
Yeah, perfectly.
Okay.
You can just take a simple 3x3 grid and try to explain me why not edges.
Like for example, I took this, right? So from 1, if I'll be using the dynamic programming pretty much, so I'll be like, okay, if I'm reaching to the 2, so if I know that from the 2 I could either come to from the 1 or from the 3 itself, right? I mean, if like if I'm reaching to the 2, like I'm at this current state, so I pretty much will have to like check all the 4 directions and get the minimum out of it. Okay, let me just take example of this middle node, the 3 node, right? So on the 3. So to the 3 I can go to like 2 itself, 2 like from 3, sorry, wait a minute, to the 3 I could come either from this 2 or this 2 or this 3 or this 4, right? So you could go like, I could take a minimum of all these 4 paths, but if I am at the 3, then I am not sure whether I have already computed the minimum to reach to the 4 or not. Like what we do in a dynamic programming, we compute it from the previous state only when we are sure that the result of the previous state is minimum itself. But at that stage I'm not sure that whether the like the what is the stored in my path to the 4, whether that is minimum or not, because I'm starting from the 0 0 itself. So that's why I thought of doing the graph.
Okay. So okay. So is it a like basically we implement a digistar on a graph, right? But it is a grid.
Yeah, yeah.
So do you need to
Yeah.
convert this grid into a graph, or you
No,
can
no,
just
no.
directly implement the
I
digistar?
can directly implement that as a Gitra. Like
Okay.
okay.
So how will you just reach out the adjacent one?
I mean of course I'll be creating a matrix, like sorry, matrix not just let me just do this of size 4. I mean this will tell me the row. Okay, wait a minute. So I can go to the 4 possible directions, right? So if I'm going to the left side, that is I'll have to decrease my column. So the row will be the row, I mean 0 itself, I'm not making any changes to the row. But if I'm going to the right side, then again my row, there will be no changes in the row, I'll be just increasing the column. If I'm be going to the up, then I'm decreasing my row, and while I'll be going down, I'm increasing my row, right? So similarly for that corresponding row, I'll just create a column, something like this one will be -1 1 and 0 and 0. So in this way, if I am at the current row, right, so let's just, so what will be the next row for this? Just current row plus ri, and yeah, the current column plus ci. In this way I'll be just able to, and this I will go from, you can say 0 to 4 itself, right? So in this way I'll be able to go to all of those 4 directions.
Okay. So just can you just quickly implement that digistar function for me to find out the
Oh yeah,
answer?
sure, no issues. So this will be integer return type, and let me just call it a minimum cost, right? I'm just assuming that I have a vector of integer passing by reference and yeah, matrix. So this will all be having. So can I assume that my matrix is not empty at all to just avoid it? I mean I'll be
Oh
having
yeah, yeah,
at least one.
yeah, yeah. Sure,
Okay,
sure.
so integer row, I mean just to avoid that few base cases, this will give me the number of rows, and sorry, this will give me the number of columns. So like you said, I'll be starting from 0 and I'll be needing another vector matrix for the cost. So vector integer, and yeah, named it as a cost. I'm just doing the row, and yeah, of course vector integer, and all of these initialize with the integer maximum, because I'm like initially I'm not sure about the cost, and I'll be just needing a priority queue for the pair. I mean yeah, pair of integer and sorry, but I think I'll be needing a comparator as well. So let me just declare
Okay, why do you need a comparator if you're using a normal priority queue?
I mean, because sir, in this case, I want that one to be at the, you can say, the top of the stock, which will have the minimum cost. So for that, I could also,
Okay, but
create a vector of this. I mean,
no,
that
but
will,
like no, like
yeah.
but if you're using a priority queue, then in the priority queue, as far as I know, there is some inbuilt sorting is done for the data that you're storing. Then why do you need a comparator for that?
I mean, because it's just that this pair will store the row and column value, but I am not sure that which row and column will be having the minimum cost. For that, I'll have to go through this. I mean, this cost matrix itself, that out of all those I and J which I have in my priority queue right now, so which one is having the minimum cost? For that, I'll have to write a comparator.
Okay,
Or
like
because I'm
because
not
you're saying
pushing the
that.
cost, because I'm not pushing my cost into the priority queue, right? I'm just pushing the I and J. So I and J correspond to some cost inside my this vector. So which one will be having minimum? I'll be popping it first, right? So
No,
for that, I'll
but like as far as I know in Registra, what we do is that we just sort our priority queue according to the cost, right? The current weight which we are standing at, and then we pick the adjacent one. All of the nodes which are currently present in a priority queue, we pick the minimum one, right? On the basis of
yeah.
cost. But if
So-
if you're not passing any cost parameter in this priority queue, on what basis you will be picking the next adjacent node?
So yeah, so that's why I was writing that comparator. I would like not the outside itself, inside the function itself, the lambda expression kind of stuff, right? So because inside this, inside this function itself, I have the cost vector, so I can use there, pretty much like a lambda expression.
Okay, like but if you're using a priority queue, then you should be you should have a way to pick the next minimum node or grid in or this cell, I can say, in this question, which is having the minimum cost till now.
Yeah.
And so how will you picking that adjacent minimum cost node if you're not passing that in the priority queue? How will you pick
So
that minimum one?
I'll be doing this right over here. I mean, yeah, this will be something like declaration type.
Yeah, but you are applying comparator on what? You should apply on cost, right?
On the cost, yeah.
Okay, like suppose if you're not, so I'm not getting how will be you picking the next adjacent minimum thing if
So
you're not
yeah, for that,
implementing it in.
instead of passing this as an pair, what I can do is I can pass this as a vector, and inside this vector by default we do the it's a max hip by default. So I can pass that greater thing, and by default it will just pick the first index element and do the what we call it comparison based on that. So I don't have to write comparator now.
Yeah, like the actual issue was that since in the normal register, if you try to analyze that thing in the normal
Yeah.
register, we try to pick the next adjacent node which is having the minimum cost, right?
Yeah.
And that's why if we put that cost into that priority queue, then we are able to pick that minimum run, right? But in this case, what you were writing, you were not passing that cost factor, right? So you will not be able, or you, what I can say, you will not be in a state to pick the next adjacent minimum cell. That's why
I
you need to
got
pass
it.
that cost, right?
Yeah,
Apart
got
from
it,
that, you need to create comparator for that, because in the priority queue, by default, the values are sorted in the descending order. That means the first greatest value will be picked up if you write on the normal priority queue.
Yeah.
But in register, we want to pick the minimum one, right? So
Minimum.
that's why,
So
yeah.
Yeah,
So that's why also
I
you
got
need to implement a comparator. So don't worry about this comparator thing. Just write on the code, considering that the priority queue will fetch you the next minimum adjustment.
Okay. So let me just do this, and I think that's fine. I'm just naming it as a min hip. So inside this, first of all, I'll have to make a cost of 0 0 equal to the matrix 0 0, right? And in this way, all I'll have to do is min hip dot push a vector whose cost of 0 0 will be the cost, and of course the 0 0 itself, right? So in this way, what I'll be doing is, of course, while my not min hip dot empty, until my min hip is not empty. So now I'll get the top element. So let me just call it as a current, and that will give me the element present at the top of min hip dot top, and I'll pop this out. So now my next job is to go to all of its adjacent, right? To all of the adjacent nodes of the current node. So first I'm just so you can say differentiating. This will be the weight to reach to this current node, and the row it is current of 1. Just I'm doing the pretty much cleaning so that I won't have to worry about this. So now R will be the node, the row of the current node, C will be the column, and the weight will be to reach to till that current node from the 0th node, right? 0 0. So now all I'll be doing is going to all of its adjacent directions, and yeah, I plus plus. I'm just assuming that this R and C are declared right there. So let me just copy paste to our, yeah. Now this is done. So I'm going there. So from this, I'll have to go to the next row. The next row will be R plus R of I, and the next column itself will be C plus C of I, right? And after that, I'll have to check if this is safe. Whether is next R and next C present inside my matrix or not, right? So for that, I'm just creating this function. I'll be writing this later on. Let's just assume that for now it is giving me that whether the next R and next C is safe or not. So now I'll have to get the previous cost of there, right? So integer, you can say the previous cost present at the cost of next of R. That is what was the previous cost to reach, to reach there with the from zero itself, right? And I can say the current cost. What is the current cost? Current cost will be weight plus matrix of next R and next C. So if I can say if previous cost was greater than current cost, then all I'll have to do is to update my cost of next R, next C with the current cost and push this into the queue. So I can do something like menheb.push my cost to do the evaluation, right? Next, next R and next C, and of course the row and column. And in this way, did I pop it out of the menu? Yes. And in the end, I think all I will have to do is to return the cost of row -1 and column -1. I think let me just check. Oh, so should I write that? If you want, then I can write it is safe function as well.
No. That's right. That's pretty.
So let me just check it. Yeah, let me just check it once. Yeah, row matrix is done. Cost for initialize the integer maximum. Menhib, and yeah, updated the cost, pushed it into the queue, and then popped the current node out, popped it out. Yeah, this one is done. Wait and R and C, then going to all of the next directions. Yeah, checked that, and previous and current cost is fine. Then I checked whether this is graded or not, and then updated this as well and pushed it into the queue. So I think, yeah, that's pretty much. I think this should be valuable. Except for that, I don't know.
Okay, so what will the time complexity of this approach?
I think it would be just n square, because I'll be just traversing all of the nodes, right? I mean, you can say the row into column. And space complexity will also be row into column, because I'm just using this cost itself, which is equal to the row and column.
Okay, so yeah, so that's all from my side, Aanchal. So if you have any questions for me, you can just ask me, then I can give the feedback.
Oh no, sir. Currently, I don't have any question. I'm not prepared for that.
Okay, no issues. That's no worries. Okay, so now coming back to feedback. To be honest, if I start giving you feedback on the first point, when we just have a brief introduction about you, I was just literally impressed about when you said that you were from a mechanical department and you started coding from the last 1 year and just trying to get fit in this coding culture, I can say.
Yeah.
So okay, when I heard that, I just wanted to know that like, do you literally have just learned the C++ fundamentals and basics? Because covering all these things in 1 year is not a very easy task to handle, right? But
yeah, but it was just pandemic year and we all are at home, so I just tried a hand out of it. Actually, I started liking the coding in my first year when I was in my first year. So like they taught C to everybody, right? To irrespective of branch, they taught C to everybody. So that was my first interaction to the C. So I first studied C to get good marks into it, but then I started liking it. So I consulted my seniors. So they were like, yeah, there were students from non-CS department as well, and they do code better. Like a lot way better than the CS and IT students. So I was like, I'm liking it, and I do have a chance to build a career into it. So why not to try it? So I just
that's great enthusiasm, right? So yeah, now coming back to the questions, right? The questions, so, like there were a few points that I want to discuss with you as a good points of yours, right? First thing is that you know your basics pretty well, right? If I talk about it, like what, suppose if I give you a question, then first thing is that you should be very clear about the structure that you want to create. Because if I give an analogy, right? If you want to build let us say a Taj Mahal kind of thing, right? So you cannot directly go and just create the machines, just gather the machines and just try to put up bricks and cement and just proceed the Taj Mahal at once. It won't work that way. So first of all, you need to have a particular structure for that. That's what a good thing of a developer, I can say, right? A developer or a software or algorithm designer, right? You first of all you need to have a basic idea how it will work and how it will go on, right? Once you have it, it is writing down a code is not that much hard. Creating an algorithm, a perfect algorithm for that is a bit, right? So I was pretty much impressed with that approach of yours. And another thing, once you have done that thing, you are pretty much quick in implementing that thing, because as I said in the earlier point, that you are pretty much confirmed about the approach that you're trying to implement. That thing is clear. The last thing is that I have seen many people, like after doing so much interviews, I have seen many people that they just once they are once they're done with writing down the entire code, they just directly jump onto the submit button. That's not the way, because you're not sure that whether it is the perfect code or not. there might be some edge cases. No matter how much good you are at the coding, you're not in god of that. There might be some edge cases that you might be missing. That means you have to check all those, that edge cases and the things that might be, there might be some typo errors as well. You have to check them all. So I was literally impressed with that idea as well, that you were just trying to cross check your code once you've written it. So that was all the good things. Yeah. So all in all, one last thing that because there's always room for improvement. So one more thing is that, as I have analyzed from that the linked list part, that you should try to cover up some more concepts about as you said, that if you want to come into that operating or like that software engineer field, like in that IT industry specifically, then you must need to cover up some more topics apart from that DSA, that is operating system, right? About DBMS, you can learn a bit about that, right? And apart from that, also you should know about like few bits and bytes about C++, like how does the pointer basically work, right? How does the behind the scenes working is going on, right? Because these are the very important thing to learn, right? So that's all about from my side feedback. And like, if I want to rate you out of 10, I can say you have done pretty much good. I will rate you 9. Because I like to be honest, I don't give anyone a 10, because there is always a room for improvement.
Sure.
So you can improve them a lot. So it was a pretty good interview, right? So all the best for your future endeavors, and you're doing good.
Thank you, sir.
Thanks a lot, Dhananjay, for taking out your valuable time for this session. And to you, Aanchal, I hope the very best. And I hope you get into a well-deserved company. And thank you all the viewers for joining in and keeping the session very engaged. So I guess that's it. Until we meet next time, stay safe, everybody.
Thank you, ma'am. Bye-bye.
Thank you.